Okay. Well, that actually is much easier because then you don't have to do some specific thing.
Yeah.
All right, I don't know who else we're gonna get. So we're just gonna jump right into it. Welcome everybody to the physics workshop. It's gonna be interesting, maybe, hopefully. So first things first, I want everybody to make a cube, stick it in their scene. You should have a scene by now. Name it whatever you want. It doesn't matter. And I want you to give it a rigid body. So, how many of you have used rigid bodies before in Unity to any extent? Okay. So basically, what a rigid body is it applies. Is this object now has physics applied to it? So, if we were to hit play right now with this rigid body on it, we would see that our nice little cube would fall away into the void and disappear forever. So it now has gravity acting upon it, basically. So I'm going to run through these different aspects of rigid body and just point out what they mean so that you have an understanding of what you might want to be changing. So mass should be pretty clear. It's how much mass the object has. If you give it a lot and then watch it fall, it will fall much faster. It's not that noticeable, but it will. What's up?
Oh, air resistance, gotcha.
Yeah. There's drag is how much air resistance it has, basically. So when you have something at 0 and let's say it doesn't have gravity against it and you push it and it's going at a certain speed, it will continue going at that exact same speed forever and will not lose any of that speed. But if you give it a lot of drag, so if I give it like 10, you'll see it falls really, really slow because it's got tons of air resistance. It's moving through like a liquid at this point. It's moving through molasses. So it's really, really slow moving in the air. Angular drag is like the exact same thing except for rotation. So it will stop it from rotating. The reason it has it by default is because not usually in your game do you want to have something that spins infinitely, unless you would specifically set it to spin infinitely, and then you probably wouldn't give it one force. You'd probably keep it at a certain pace. So use gravity. If you don't get that, I'm sorry. Is kinematic. So when an object is kinematic, it basically is not affected by normal physics, but it's treated as a physics object. So it can't be moved via physics at all. If this cube is kinematic and I were to make a second one right above it that is not kinematic, the top one would fall, hit the bottom one, and the bottom one wouldn't do anything. It would not be moved. It can't be moved. It can be moved by directly changing its transform. So if you have, for instance, a script that has it increasing the x direction constantly, it will move in the game, but it won't be affected by physics stuff. This is helpful if you have a player that is moved by moving their transform or by animation or something, that you wouldn't want your player to get hit by something and get launched. Now, if you're doing ragdoll physics, obviously you would, but for a lot of times you wouldn't want that for different objects. So
also, kinematic works in a relative type of form that if you have it being the child of something, when that parent moves, it will also move. So in relative space to its parent, it won't move. Since it has no parent, the parent is the entire space. So in this one, it does not move compared to everything.
Yeah, because that's based on just child stuff. If the parent moves, the child will always move with it. So that's a good point. Interpolation. So I'm going to go over this really quick because this is kind of weird, but I'm going to draw something because this is actually pretty helpful. So Unity has a bunch of different stuff running at the exact at around the same time. You like Mitra. It's got update. And then it's got another thing going. It's called fixed update. So fixed update is used for physics. Update is used for most other things. The thing is, fixed update has, as you might guess from the name, a fixed amount of time between each frame. Regardless of how badly your game is running, it will always calculate physics-related stuff at the exact same speed all throughout. Update depends on what you have in your game. If your game has a lot of stuff, it will run slowly. The visuals will update really choppy, and that is actually the speed at which it is updating. So you could have quick updates, and then something happens where it takes that long to get back into things. So you need to keep that in mind when you're scripting stuff, because you always do physics-related stuff in fixed update, but for instance, input is taken in update. If you did input in fixed update, and there was a situation where they weren't lined up, you might press the button and nothing might happen. You might have actually just nothing happen because this is where it's actually getting input. So if you hit space right here, and this one ended by the time this one even started, you'll hit space, it'll recognize you hit space, but it won't give that true value in fixed update. So if you had that input in fixed update, it would ignore it because it wouldn't actually have the value of true because they're not happening at the same time. So something really important to keep in mind. So basically interpolate is it's basically when graphics and physics will be updating. And if you have it on subtle, or not my bad, it is subtle most of the time on the discrepancies between physics and graphics. But when you have it on your player and your camera's following them, it can be really painfully obvious if you're controlling your player through physics. So in that situation, you would want to turn on interpolation. Don't worry about extrapolate. Don't even look at that. But if you had a player object, it would be a good idea to turn on interpolate so that, is that how you pronounce it? Is it interpolate? I don't know. Okay, that word. So you would want to turn it on for the player if things were looking choppy, if you wanted it to look more smooth so that these were running in sync better. Collision detection. Collision detection is important for how fast your object is moving. So if you have two objects moving at pretty reasonable speeds and they hit each other, you'll be fine using discrete. It doesn't matter. However, if you have a really fast object, aka a bullet, if the frames that it's calculating fixed update, if it's moving, so if this is your guy and the bullet is moving towards him, if it moves this much per frame, it wouldn't even pick up that it's hitting the object because it would be moving through it and it wouldn't even be registering it there because it's already moving to the next position past him in that frame. So in order to avoid that, you can turn on better collision detection. So for a bullet, you would want continuous dynamic is what it's called. And basically that will give it as many frames as the system can spare for calculating what it's going to hit. And then for something being hit by a fast-moving object, you would actually just want continuous. So they are different, and so if basically the receiver of fast-moving object, you would want continuous. The sender would be continuous dynamic. Again, not really used too much because most of the time if you're doing bullets or something similar, you'd be using array. So you'd be using basically an instant check for the next collider rather than trying to actually throw a bullet and see if it hits, because that doesn't usually work out too well, but in some situations it is useful. And then constraints are super easy. Basically, constraints, you can just freeze parts of the transform. So you've got position and rotation up here. So if I were to freeze the Y position, and this is using gravity, it's not kinematic, it just should be able to move down. It won't, because I've frozen the X position. If I let go, it'll start falling. I can go back and forth. And then freeze rotation is the exact same thing, but for how it's actually rotating. So a lot of the time when you're doing a player, you would freeze the rotation so that your player wouldn't be doing flips off of rocks and whatnot. You'd probably want them staying upright most of the time, especially if you have a camera attached to them. If you have a camera attached to your object as a child, so it's following them exactly on top of them, you would not want to have rotation up because it will, let's actually see that. You'll see. Let's make this kinematic. Let's not lock these. Let's stick the camera on here. Okay. So when this thing falls, it looks fine. And then when it hits, the camera will flip and rotate and turn with it, which if you're trying to make a game that doesn't make the player vomit constantly, you probably don't want to do that. So in that situation, you'd want to freeze rotation. Now, if you had your object rotating and you didn't necessarily want to stop the rotation for the camera, you could have a script where the camera follows the player, not as a child, but as just a separate object, which would work okay. So another thing to keep in mind is what's called physics materials. So if you right-click in Assets and you go to Create, you can go to, not Material, dodge that, near the bottom, Physics Material, or Physic Material. Basically, this will allow you to determine what your object is made of. So if you had an object that was made of ice, you would turn friction to 0, and then you would slide basically perfectly around. If you wanted something made of rubber, so it would not slide at all, you would turn it way up. So I'm going to make a plane bit below the player. I'm going to give it some really heavy rotation that the camera can see, actually. That should be good. So if you to change a physics material, if you go to the collider on the object, it will have a material spot, and you can select the material that you've done. So now my material has no friction, and I'm actually going to give it to the plane too, which I'll explain in a sec about why you want to give it to both for what we have. So if I were to press play, this object has no problem just sliding off. I forgot that I froze the rotation. I'm actually also going to line this up so we can actually see it rotate correctly.
How did you line up?
Huh?
How did you line it up?
I just changed the rotation of Z to 45, and I just dragged it.
All right. So you memorize the number.
Yep. So now, when you press play, it slides absolutely no problem. If we change the material so that it has a lot of friction, or about how much it had originally, you'll see that it will, instead of sliding, will start to roll because it can't actually move down enough. So this is going to be a physics. How many of you have taken physics? sort of a refresher in this. Dynamic friction is the friction of when the object is actually already moving. So if you have high dynamic friction, your object won't be able to slide as it's moving. Static friction is the amount of force it would need to actually start moving. So if that was high, so if you had high static and low dynamic, your object would have trouble to start moving, but once it actually is moving, it would slide. It's not because it's rolling, but believe me on this one. What?
It just has momentum.
Yeah, right now. So there's another aspect of physics materials, the fun stuff, bounciness. So when you have something, so all of these are scale 0 to 1. When you have a high bounciness value, or all the way at 1, it will basically just perfectly retain its energy, and it will continuously bounce to the same point. Now, because of float calculations in Unity, it will actually bounce a little bit higher a lot of the time. So if I were to leave this, it would just continuously bounce higher and higher because calculations are weird. So that's why it's starting to go off screen now. So what I mentioned with why we're doing it to both is because of the combine value. I'll go over this quick. This isn't that important. Basically, it just determines which material to use when two objects are touching. So averages out the friction values. So if one of the objects was at 1 for both and the other was at 0 for both, it would do 0.5. The object would move at 0.5. If you did the minimum, it would choose the minimum between them. If you did the max, if you did multiply, it would multiply them together, which is always interesting to see. And maximum will just choose the maximum between them. Balance is the exact same thing, just in regards to bouncing. So last thing before we actually start doing things that are cool, depending on what you think. I'm just going to reset these. There's a few things in physics settings that are pretty important. So if you go over to the edit, the top left, and you go to project settings, and then you go to physics, you'll open up this menu on the right. If you were in one of the last workshops that Nate was doing, he opened this up for the collision matrix at the bottom. There's only like 3 things here that you should actually look at. The rest are really weird, and if you mess with them, you might make your game do some really strange stuff. So I encourage you to go and look at what these do, or don't. I mean, you really won't have to worry about it. Basically, the important stuff is you can change gravity. So if I made this 9.81 as well as the y, my object will no longer fall directly down. It'll actually just fall directly diagonal. So you can just easily change the gravity. If you change the gravity here, it will change it for all objects. Do you guys have any ideas of how you would change one object gravity against it? Throw your hands up. Any ideas?
There is a gravity constant, but that doesn't really change angle.
Yeah. Basically what you could do, all gravity is doing is for all of these objects, it is just adding that force in the y every frame. So if you wanted to make a 0 gravity, if you wanted to make it so that your one object had 0 gravity and you didn't want to just turn off use gravity, you could add 9.81 force in the y direction to just counteract it. So as long as you did something every frame, you'd be doing the exact same thing as gravity. So you could counteract each one by messing with those values if you wanted to change just 1 or 2 or however many objects, but you didn't want to change the entire global.
So, constant though? Huh? You could do that with the constant in rigid body though. Just set it to 0.
The what?
So go to your cube, and it should be right next to gravity. There's a gravity constant. Isn't there?
No.
Okay,
in script there might be.
Okay.
But there's multiple ways to do just about everything. But from what I've found, it's pretty easy to just add those forces. Okay, and the other thing is default material. We just went over a little bit of physics materials. This is set to none by default, which means this is if you don't specify a material, it will choose this it will choose whatever is in this menu. So if I had bouncy and then I made a bunch of new objects and didn't specify anything, they would all have the bouncy material. You can of course set that to whatever you want, but changing it here will change the default, which can be pretty helpful. Ignore everything else, literally everything else, except the layer collision matrix. We did a little bit of that in Nate's workshop. Do you guys remember that at all? Okay, basically, objects have different layers. So you can set the layer for an object. So if I had Greg and I gave it, instead of layer default, I gave it layer water, because that's one of the predefined ones in Unity. And then I went to edit project settings physics. I can determine whether objects in different layers will collide with each other. So for instance, I have default and water. So if I'm looking at the cross between them, I can turn that off. So now default and water will no longer collide with each other. And because my plane is default and my cube is water, when I hit play, they'll completely ignore each other. So this is really helpful. So for instance, Nate was doing a pinball workshop. So you wouldn't want the flippers, when they flip up, you wouldn't want them colliding with the walls of the pinball machine, with pretty much anything except the ball. So you could put the flippers and the ball, or you could put the flippers in a separate layer and then mess with the matrix so that they'll only collide with the ball, and that's it. So it's pretty useful a lot of the time in just making it so that certain objects won't hit each other. I'm going to put that back to default. So now we get to the fun stuff. So I want you to hit create and make a C# script and call it literally whatever the fuck you want. And open it up. Once mine eventually opens up. Come on, laptop, you can do it. I believe in you. Sort of. Alright. My computer's pretty slow. Wow. Hey, there we go. Oh, there we go. So, what I sort of mentioned before with update and fixed update, so in this situation, we will actually want to make a separate method here called void fixed update with capital F and capital U. And what this will do is this is where we will want to put all of our physics stuff. You can add physics stuff in update, but it will not work. It won't do it continuously. It'll do it freaky along update. So you might have some weird discrepancies and stuff you don't really want. So first things first, since we'll be doing, so we'll be attaching this to the cube. So we will want to put we'll want to get that rigid body. So the first thing we can do is we can make a private rigid body RB. To be fair, private is by default if you don't specify. So you can just do rigid body RB, doesn't matter. I usually specify private for this kind of stuff just so that when I'm looking back I can remember why I was making it. So then we can do RB equals get component rigid body. So this will get the components, this will get the rigid body of whatever object this is attached to. We could surround it in like a try-catch to make sure that the object actually has a rigid body, but since we can just put it on an object that has one, we don't need to, so it's fine as is. What's up?
The thing I was thinking about is only for 2D physics. You can change the gravity constant in 2D.
Oh, it's only in 2D?
Yeah.
Oh, okay, okay. So yeah, if you wanted to change gravity in 3D, you'd have to do the forces. So now we've got our rigid body. So as an example of input and changing physics, this is going to look kind of silly, but too bad. So what we're going to do is we're going to create a few more objects. So we're going to make a public float move force. So when we are moving our object, instead of giving it a constant, instead of saying, okay, move it at force of 10, instead we can change it from the editor because it's a public variable, so we can set it to 10, we can set it to 100 without having to come back into the code. So we can do that, and then we'll actually also need a Boolean for pressed button. So this is going to look kind of silly when I'm programming it, but this is sort of the best way to do it. Basically, now we can say in our update, we could say if input, so we're now getting the input, dot get key, and then you can specify whatever key you want. I'm going to do space. So I'm going to do key code dot space. You can also just enter. You can also just enter for a key the actual character like that. But I prefer to do key code because then I can get arrow keys, function keys at the top, caps lock, whatever. So I usually prefer to just do key code just to be sure that I'm doing the right value. So now we're going to say pressed button is equal to true, and then an else saying pressed button is equal to false. It is kind of silly doing this, but basically we're saying when we're getting the key, all frames where we're getting the key of, in this case, space, I want this Boolean to be true, and all other keys I want it to be false. So why do you guys think we might want to do it like that? If we're going to be doing something in physics relating to this down here. So the reason being is we wouldn't want to put input in fixed update because it might get all fucked up because that's not where input is read, it's read in update. And we can't put the physics stuff in updates. We have to have them communicate somehow, but we can't just like call a method when it's true because it needs to be in fixed update. So the way around that is, again, kind of silly, but we can then say in fixed update, if pressed button, then in there we can put our physics stuff. So basically what that's saying is, while the button's being held, do the physics thing in fixed update. It's kind of silly looking because, I mean, if you had professors watching this, they'd probably start crying seeing you use Booleans like this instead of finding something clever, but that's sort of the best way to go about it, so too bad. So now here, we're going to say, so we can do a few things with physics. So one of the easiest ways to change things is to change the velocity. So in this situation, I want to make our object go upwards. So change in the y direction while we're holding space, sort of like a jump. Although in this situation, it'd be sort of like if your character had a jetpack and they were continuously going up rather than a actual single jump, because single jumps are actually a little bit harder to program than you might think because we need to check if we're on the floor and a bunch of other stuff. So what I can do is I can just directly change the velocity. So I can say is equal to new vector 3, and I can give it its current velocity at x. Goodness, it's covering everything. So I can give it its current velocity at x. Then I can give it the value I want, so move force. And I can give it rb.velocity.z, so it's current velocity at z. The reason I'm writing it like this is because we wouldn't want to overwrite the x and the z values. If our character was running really quickly and we wanted to use our jetpack, we wouldn't want to just completely stop and start using the jetpack we wouldn't want to affect x and z, so that would sort of be the default. I'm putting it on the new lines because my text is big and you can't see it very well. So you don't have to do it like that if you don't want to. So now if we go, so let's test this. Let's see what it does. So go back into Unity. And we want to grab our cube. So we want to add this script. So there's a lot of different ways to add it. You can click and drag. You can also just look up script, or your script. My bad. I named mine Keck. Don't judge me. So then I can give it a certain. So then I can specify the move force. So if I say 10, I'll give that. So now my object will fall. Should fall. And when I'm holding space, it'll go up. Now, what could you see being an issue with just changing velocity like that?
You don't know your jump height?
Oh no, I mean, if you specified a certain velocity, you could jump. Changing velocity is actually good for pressing space, but why wouldn't you want to use it for, say, movement?
Or just
The reason being, if you had an external force being applied, so let's say you were on a conveyor belt, so you were then setting it backwards, if you were directly setting the velocity, that conveyor belt would have no effect. Because every frame you're just giving it the velocity you want. You wouldn't be able to take away from it. So by instead adding a force, so instead of just directly changing the velocity, adding an actual force to it, you could then add a force in the opposite direction to change it somehow. So for instance, if we were to make gravity really heavy on this object, and we had our velocity thing, when we let go of space, it would fall much quicker, but holding space, it wouldn't affect it at all. And we don't want that. We don't want gravity having no effect. We want it to have some effect. So instead of doing this, we're going to do something a little bit better in terms of that. So we're going to do rb.addForce. So now we need to give it a vector. So there's a few different ways to do this. We could do a new vector 3 and give it 0 and x and z and then give it a y position, but there's actually a shorthand way of writing that. So the shorthand way is vector3.up. And as it says here, shorthand for writing 0, 1, 0. And then we can just multiply that by move force. So what it's saying is we're taking a vector of 0, 1, 0, and we're multiplying it by, I think our thing was at 10. So that's the same as writing 0, 10, 0. It's just shorter to write. And then there's actually one optional thing to put in here as well. And this can be pretty important for determining stuff. So force mode has a few different values that you can use for it. So it gives you a little description right here as you scroll through them. Acceleration is if you're giving it a continuous force. So this would be used for movement. This would be used for gravity, that kind of stuff. Like something that's going every frame, you'd want to use acceleration or force. And the difference is acceleration ignores its mass. So if you had a really heavy object and then a normal object, not normal, but a not heavy object, and you were to give them the same acceleration, they would be given the same force. Whereas if you use force, it uses its mass, so the heavy object would move hardly at all, and the normal one would zip right by. And then impulse and velocity change are the same idea with mass and not mass, but it's instant. So you would use this for like a jump, a dodge. You'd want to apply these. So in this situation, we would want to use force, because if our character has a jetpack and they're suddenly really heavy, we wouldn't want them to just be able to zip right up regardless. So if we jump back here and try it again, we're going to have to increase the force by a lot, because actually at 10, when it was directly changing the velocity, it was setting it. Here we're adding a force. So I'll put it at 50, see how that looks. Yep. Now, when it's falling at a high speed, actually can't even see it falling. When it's falling at a pretty high speed, notice that it doesn't just jump up instantly like velocity does anymore. Now it will have some time that it takes to go back to start moving back up. Depending on what you want, you would use either way. For instance, jumping most of the time for your character, if you have a double jump in midair, you would not want to add a force. That would be a very bad idea, because in that situation, if you're moving down really fast and you try to double jump, you won't actually double jump. You'll slow down for a sec and then keep going, because it won't actually, by changing the velocity directly for a jump, you're guaranteeing that it's going to jump at the same speed, regardless of how you're falling and what you're doing. So depending on what you're doing, you'd want to use add force, you'd want to use velocity. It's sort of, you have to make that decision based on what you're actually looking for. So now I want our object to be able to do something else. So I'm going to create a float called horizontal, a float called vertical. And what these will store is these will store the player's horizontal and vertical controls. So if they're holding W, so if they're holding up, we would want our vertical to be at 1. If they're holding down, we'd want it to be at -1. Nothing would be at 0. So we would store these for use later. And the other thing we'll need is a public float. Let's call it torque force. So now we get it. Now we get to do some torque stuff. Oh boy. It's not nearly as horrifying as it was in physics, I guarantee it, because I was not good at that, I'll tell you that much. So now, in our update, where we're getting inputs, we're going to give it another set of inputs. So we're going to say our horizontal, so this is every single frame, will be equal to input.getAxis, and then we'll give it the name horizontal. Don't spell that wrong. It won't like it. So what that's saying is Unity has in its input 2 axes called horizontal and vertical, and when you're pushing a direction in either of those, that value will be set to from -1 to 1, depending on if it's down or up, basically, or left or right. There's another aspect of getAxis. It's called getAxis fixed. Basically, let's see, I think it is. Why does it give me a red? getAxis raw, my bad. Okay, getAxis. So getAxis will give a gradient from -1 to 1, which is really good for controllers, because on your thumbstick, if you're only holding a little bit, you would want to only get a little bit. However, on keyboard, that's not very preferable, because on keyboard, if you hold D, so you're holding, or right arrow, whatever, if you're holding to the right, horizontal will move towards 1, so it'll take a few seconds to actually get to the direction you're going, which feels awful for controlling keyboard. You don't want slow moving input. So if you're doing keyboard controls, you would want to use getAxis raw, because that basically says there are only 3 values, -1, 0, and 1. So if you hit right, it'll instantly go all the way to 1. But getAxis raw is really bad for controllers, because you wouldn't want it that if you barely tap the control stick, it goes full force to the right. You wouldn't. That would be not at all preferable. So because we're doing keyboard here, I'm going to do getAxis raw. And then I'm going to do the same thing for vertical. getAxis raw, and do vertical. So if you're curious about the different controls in Unity, you can actually go to the editor and edit project settings, and you should see input very top. And this will actually give you, once it opens, eventually, there we go, it'll give you all different aspects of the predefined stuff. So here we see horizontal and vertical, and it's a lot of complicated stuff, but all you really need to worry about is that it exists, and this is the namespace for it. And you can see it says left and right for horizontal, or A and D, which are the usual two control schemes for keyboard. But this would also be where you can get different buttons. So like fire 1, we would know is left control, which it should not be, because why the fuck would you use left control for anything that would be firing? But you could then change it and specify something else. So that this is a good thing to know, just so that if you wanted to change some of the inputs, you could. So now back to our code. So now we've got our values for the way we want to go. So in fixed update, we can give, so we don't actually need an if statement for what we just did, because adding a force of 0 doesn't actually do anything. And because when you're not pressing anything, horizontal and vertical will be 0, we don't even have to worry about an if statement. So we can then say rb.add torque. We're going to get some rotation going. And we can do the shorthand way of writing things or the longhand. So if we wanted to do the longhand way, which is actually shorter in this situation, but you can really use either one. We would then say this, we would be adding a torque of horizontal times our torque force. So that's what we would want in the x direction. And then, oh, actually, my bad. This is where it gets kind of goofy, because if torque doesn't, you got to remember rotation stuff. What is it, the right hand rule, right? You hold up your thumb and it does some goofy shit. So you can write it that way. I wrote it down as the other way, so I'm just going to do that before I look like an idiot up here trying to figure this out, because I already did this. So vector3.up times horizontal plus vector3.left times vertical. So if you remember the right-hand rule, if we're looking up, we would want that to be left and right, and left would be up and down for controlling our rotation. And then we would multiply all of that times our torque force, because with the stuff in parentheses, we're now saying up is times horizontal. So if we're holding up, it'll be 0, 1, 0. And then we're adding left times vertical, so we're also holding the other way. We would get 1, 1, 0. And then we're multiplying that by the actual torque that we want. And this also has a force mode. And we're going to also just give it acceleration, because we're doing it continuously. If we wanted to spin our object with one solid single force, we would want to use impulse or velocity change, the other one. So now this should work. Let's see. No errors. Please. Yes. So now, are you guys following along okay? Is anybody behind? We're good? Okay. So let's give our torque force something. Let's give it 10. And I'm actually going to turn angular drag off so we can see it spin in all its glory. And then the last thing is I'm going to actually turn off gravity so that we can actually see it spinning. Otherwise, it'll just fall instantly. So now, holding space will still make it go up. Don't press space. No gravity. It'll go away. But now, when we hold directions, we can cause it to spin in different ways. I just realized my controls are inverted, so I guess I didn't do that stupid right-hand stuff correctly when I made this. It's alright, whatever, it's a feature now. So we now have control over torque, and we have control over force, and make it launch. So now I want to actually give you guys a challenge for this. Alright, so we're going to remove, actually, we're just going to delete Plane and Greg, alright? So get rid of them. So you're going to need to create 2 planes, one plane at 0, 0, 0, then one plane at 20, 0, 0, a cube at, not as a part of plane, a cube at 0, 1, 0, and then move your camera. Did you guys get all those? Okay. And then get your camera at 10, 5, negative 20. That should give you a good view of your cube and those 2 platforms. And my challenge to you for the next however many minutes, depends on what I feel like, is to make a script that you can attach to the cube that will let you control the player moving in different directions, and when you press space, they jump upwards, and your goal is to jump from the left plane to the right plane. You can reuse all parts of the code we just wrote. Don't use torque. Torque's not going to be helpful here. That was just more of a showcase of that. And the other thing that I will give you to help out is if you do get key down instead of get key, that will be the one frame that you press it. So if you had for your jump get key down, you could then change the velocity just once when you press it, rather than get key. So it wouldn't be calling it every frame. You could just call it once if you wanted to do that. If you guys have any questions, feel free to shout at me. You doing it too, Nate?
I'm fixing up and zero. Game check.
Oh, okay. Okay. Is anybody play Halloween? New Halloween update came out with a bunch of new content. I haven't actually seen it.
I think you can.
It might be PC only. I'm not sure. It's like.
You can play it on the PC.
Yeah, I know that. It might be on consoles.
I mean, I know a lot of people use controller to play it.
Yeah. It has like no requirements, so it's not a very big game.
No spec requirements?
Not really. I mean, this laptop runs it pretty badly. It's pretty laggy, but I mean, this laptop doesn't run anything, so.
Yeah.
This laptop has trouble running Terraria sometimes, so I mean, it's not very good. So have you guys been doing, did you guys do movement first then? Or jumping first? How's it going? How's it going?
Bad, because even just crashed.
That's not good. That's not good at all.
Just my life.
You guys stuck anywhere that you need help with an idea for something? Okay. Trying to help. Anybody watch Stranger Things season 2? We got through episode 6, so we got 3 more of them.
Well, did you actually watch it though? Did you? You said you were working on this at the same time.
Yeah, after class.
Oh, after,
I
gotcha.
skipped some class.
Skip
I skipped 2:30, that was it.
Oh, it's
That was
okay.
it.
We didn't really.
2:30.
I don't remember what we did, to be honest.
I don't remember what we were doing.
Oh, we did a robot problem. It's actually interesting.
Oh.
The one time.
The one time. It's fine.
Do you guys have someone?
Yes.
Yup.
And Georgie.
Georgie or the PA? Or?
He's like our assistant professor. You don't know.
Oh yeah, that weird stuff happened last year as well, but like we didn't have enough students to need one, so that teacher that was assigned that just disappeared.
Oh.
We should got 2 teachers that teach you guys?
Yeah. Well, Selma's the primary one, and then Georgie is like a recitation
Oh,
teacher, so.
yeah. An actual teacher does them?
Yes.
Oh wait, the TAs last year were horrible.
There's only 2 recitation times. It's not like it's
Yeah,
so
but-
a lot.
Oh, you guys got 2 recitations? We only had 1.
More people in the class maybe.
Maybe there's just more people taking it fall rather than spring. So.
I'm officially scarred. It's from recitation.
Oh,
Apparently in the chemistry learning community,
Yeah.
there's you get credit for doing like some activities in the working community outside of the in class, wherever. And one of the activities is going to a pool party at the professor's house,
Oh, over in
which is kind of sketchy.
that's creepy. That's super creepy. I'm not gonna lie. That's super
It was
weird.
extra funny too because I know two friends in it. One's a guy, one's a girl, and the girl got the message like a week before the guy, maybe not a week, but a few days at least. And it was so funny because at first we were like, wait, is he fucking the girls? And then he got it like.
Yeah, that worries me a little bit. But what professor is it? Is it Gerd?
No clue.
Oh, no! That'd be so weird. I miss Gerd though. He's like kind of funny. I mean, I hated class with him, but like,
He's a cool guy.
yeah.
Had a lot of passion for the work. I like Prabhu. I didn't think I'd like him very much, but he says some pretty funny stuff. When
Mitra?
yeah, like when he low-key like flamed Mitra and then also destroyed the dean's office at the same time. I was like, wow, ooh, damn, this guy's throwing fire today.
I was hoping he would tell us which person he'd prioritize, students or Mitra. It's okay, it was a good example still. I was just a little disappointed.
Oh my god, that was so funny.
what was this?
He was talking about giving priorities for certain error handlings or just exception handlings in processors and whatnot. And he was like, so if I get a call and one says from the dean's office and the other says from a student, I need to prioritize which one I need to pick up because I can only pick up one. And he didn't say the dean's office, he said the student. And he said because the dean's office will most likely put him on some BS committee that'll ruin an entire year or two. So he'll just ignore them and talk to the student. And we were laughing pretty hard. You can't just say that. And then he roasted Mitra too. Said, new guy like Mitra will try to do everything he can, but I've been here. I know the system. I'm not going to listen to that.
I just like how he said that Mitra was too social. Like, he just has to butt into everything.
Mm-hmm.
You're not wrong.
Is it moving?
Yeah, he got his word.
Is it jumping?
Yeah, he like got it to the other platform.
It's got a
Perfect.
jump, it's just a fly.
Works. Oh yeah, you can't just turn off gravity, by the way. Okay.
I made it back.
Wait, like you just went so fast you got over to the other side? Without jumping at all?
Have you seen
No, I just left the space in where you.
Oh yeah, I
the
mean,
Big Rig
just-
racing game?
the what?
I got my
Big
bit
Rigs.
back.
No?
Oh, big rigs?
Yeah, I think the Angry Video Game Nerd player.
Yeah, it's awful.
It's an actual marketed game. Like you can buy it at the store. I don't think anymore. It's like $40, and it's so poorly bug tested. It's like a truck racing game, but like semis. And if you go backwards, there's no limit on acceleration.
So you just go backwards
And
and
the
you'll.
collision is terrible all over the map.
I don't think there is collision with like buildings. I think you just go right through.
You do like the mountain sort of collides.
And like,
The
yeah,
ditch doesn't collide.
it's really weird. Your truck doesn't regard uphills and downhills. It just
It just
goes up them. So you'll go up to a hill and you'll just be like, "Meh." It's oh my god, it's bad.
Alright, there's a BMX game.
Did you guys get it to work?
It's super shitty.
Ish.
I cheated, but yeah.
All right. Well, we'll be uploading this later, and I'll be going over a
that
solution
if you slow
of
down
like
enemies, right,
one way to go about
you
it. So
can't get up
you can
to
check that out.
And it's based off of
Thanks for coming.
acceleration that you have in them. It's not like you just keep going at it. The tiniest speed that you
By the way,
can.
there is a part 2 to this
It's like
workshop in
you go up
I think
and
2
you
weeks,
go up.
where we'll be doing some really much more interesting, much more complicated player stuff like wall
Yeah, I
jumping
think it's supposed to be
and
a racing game, right? But like the
zero gravity zones and whatever else, like all that kind of stuff. So
Oh, we have that. Sounds like a game.
you go forward and then go back, you win.
Don't let me.
Like you don't have to like go around the map to hit the flags, just go forward a little and then back.
They're lazy.
No,
You don't
no.
learn.
Stop trying to get suicide.
What would be fun would be a steeplechase type of racing game.
are you guys done?
Open world, but
Enough?
you can take any
Okay.
route you
Well,
want,
I'm gonna go over my solution to it
which was the
so-
traditional steeplechase.
of what I did.
No! You're so frustrated.
Have fun. It's good.
It's got 9 episodes this season. Yay!
Already?
Yeah, they release all of them. That's why we binged like all of them.
Alright.
You can just go watch from. See you in 9 hours. All right.
Not Friday.
No, it was still pretty bad.
All right. I'm recording this, so I know it's just YouTube, but I need to actually like also do things. So I'm gonna freeze my rotation of my object first of all because I don't want it doing any weird stuff with movement, and then I'm gonna call. Give me a name for the script. Not with the A.
And 2 to the third.
Hmm?
And 2 to the third.
No.
That's Nate.
I know, but no. Stop it. All right.
And 16 times.
So for mine, I need to get my notes out. Forgot about that. So here's what I did for mine. So first of all, I made 2 floats for movement and jumping. Because I want to be able to mess with both of those values to control my speed and how high I jump and whatnot. Then I'm going to need a bool for jump so that it knows when to actually give the force for jumping. And then float horizontal, float vertical, same as we did for the other script for that reason. And then finally, our classic rigid body RB. So first things first, I'm going to set RB to get components so that it's now actually giving us the rigid body attached. And then I'm also going to make, I just know I'm going to need fixed update for this, so I'm going to make that now. So first thing I'm going to do is I'm going to set horizontal and vertical. So horizontal equal to input dot get axis raw. Horizontal. So I'm going to get those 2 values, and then I'm also going to get input.getKey down. God damn it. Keycode.space.
Is spelling a problem today?
No. No, it wasn't. No, that wasn't a spelling error. That was I accidentally put in kek because I forgot to name my script that. So, okay. So now, then I'm going to just set jump equal to true here, and this is all my update's going to do. It's going to be giving me the horizontal value, the vertical value, and it's going to be telling me the frame I put down space, jump's going to be set to true. So then, down here, there are a lot of ways to do movement. I had like 4 different ways to write it, but I'm just going to do this way, the way I actually decided to, because I don't really feel like writing out a bunch of different ways and then erasing them. You already saw the reasons why you would want to do certain things. So vector3 dot right times horizontal plus vector3 dot forwards, not up, forward, because we don't actually want to be moving in the y-axis. We want to be moving in the z, in the back. So that times move force, and I'm going to do force mode dot acceleration. So now that will be our movement. That will control our movement. So it'll always be moving in the x-axis for horizontal and z-axis for our vertical movement. Then I'm going to add if jump. So now if our jump value is true, first thing we're going to do is set jump to false. And then I'm actually going to change the velocity directly so that if I did it in the air, it wouldn't be janky. It would also work just fine. So I want to conserve the x. I want to make the y our jump force. And then I also want to conserve the z so that those won't be changed. So this jump equals false thing is basically just saying the frame we get space, set jump to true, and whenever we can next in fixed update, whenever it gets there, it will then reset it to false so that it will call it the first physics update it can. Which is usually how you want to go about it. It's kind of silly, but oh my god. Yeah, can you tell I'm sick? Sorry about that. Thanks for sticking with it, I guess. So now we got our cube. I'm going to add in our script. I'm going to add in our script. I'm going to give it a move force of 20, jump force of 10, maybe should be fine. We'll see. So our object moves around just fine. Oh, and it falls off, and it'll jump. And if I press space, it jumps. If I hold space, it still only jumps once. So that would be the advantage of doing get key down. So now I can just jump. Okay. Oh. Okay. I'm over adjusting. So I can jump over to the right platform just fine. Yay! Woo! We did it. So did you go about it about the same as I did?
I just made 5 different balloons for up, left, right.
Okay, you're making a joke. Are you joking?
I'm not joking. I didn't care.
Don't do that.
I know.
Oh my
I
god.
told Morgan as I was doing like, yeah, this is definitely not the right way to do it.
Yeah, you definitely don't want to just make a bunch of...
I was the first one done, so that's what matters.
I mean, you're right. If it works, it works, but it might run a lot slower. It might run a lot slower depending on what's going on. But
If this is all that's going on now.
You're right. If this is all that's going on, but in a full game, if you start designing a bunch of things like that, your code might become super convoluted and it might start running like garbage. So that's actually all I have for this workshop. Basics of physics, adding forces, adding torques. In 2 weeks, should be 2 weeks, might be next week, depending on if Iz can do her thing this time. I'll be doing sort of a part 2 for this, but instead of just about physics, it'll be about controlling the player. So we'll get into stuff like how do you make it so the player only jumps once, and how to do wall jumping, and sliding down walls, and zero gravity zones, and all that kind of stuff. So it'll be a lot more driven by a single goal. So I'll let you download a big sort of an obstacle course, and we will program our way through the obstacle course. So we'll add new features to get past the obstacles. So it'll be a lot of fun. Check it out. If you missed this workshop, show up anyways or watch us online. I don't know how you'd be listening to this if you're not already watching it, so it's fine. So that's it. That's all I got. Go forth, make games, be awesome. I'm sick. Peace. How in the world do I...
No button, that's a square right now.
You're almost there.